Hello people, this is Christian and you are welcome back to Don't Have channel. So this video is going to be the practical session of our data preprocessing. Okay, so the prerequisite for this video is going to be installation of Python, installation of pandas which comes along with Jupyter notebook, and also downloading of the data set. Okay, so when you come to Kaggle, I will leave the link down below. You can come here and then download your dataset. Okay, and once you are done you'll be good to go. So it's going to be an interesting video, trust me. So for this and more, kindly click on the subscribe button. If you haven't, like this video, share your comments in the comment section, and let's start. All right, so in this video there are a couple of steps we are going to take, okay, or consider, and by the time we get to the last one, trust me, our data will be in the right form. So before we start, I would like us to look at how, or take a look at how our data set looks. Okay, so once you download it, you open it's in a CSV file, and as you can see here, we have combination of categorical and numerical data. Okay, so for instance, the country is a categorical as well as the status, right? And the rest of them are numerical. Even the numerical, you could see that we have continuous data and then discrete, right? Yeah, so this is how the data set looks. Now let's get back to step one. So the step one says we should import the libraries. Okay, so the necessary libraries we'll be needing for this, we have to import them. Okay, and the first one we are going to import is pandas. So I'm just going to type import pandas. Okay, oops, pandas as pd. All right, and then we're also going to import numpy as np. We're also going to import cbon as sns. All right, and we're also going to import matplot. Okay, matplotlib dot pyplot. All right, as plt. Yeah, so these are the libraries we are going to import, and once you are done importing them, you can run them. Hopefully you don't get any errors. Okay, the next step is we have to read the data set. Okay, so we are going to, let's wait for it to finish. All right, so it's done. So what you are going to do is we are going to import our data set, or we are going to read our data set into a variable called df. And our data set, you are going to use panda, so pd read underscore csv. Okay, and inside it we are going to provide a name of our data set. So your data set is supposed to be in the root directory. Okay, when I say root directory, I mean the directory where you created, or your Jupyter file is inside. Okay, so where you created your Jupyter file, forgive me if I didn't show you. Okay, so this is my directory, so you can just go ahead and create a new by clicking on new and then python 3. Okay, so that will create a new file for you, and inside that same directory you can copy or paste your data set right there. Okay, and once you are done, what you have to do is just copy the name of the data set including the extension, and we are going to paste it right here. Okay, so this is how we are going to read our data. So we are going to run it, and the shortcut for that is shift enter. It's going to run it for you, or you can just come here and run it. Okay, so once you are done running it, we can check some information about our data. So we can just say df.head. Okay, and I'm going to run it. So the head function gives us the first 5 rows, okay, of our data set. And as you can see, we have from 0 to 4, which means 5 rows, and we have our columns right here that's concatenated the columns. Yeah, but at least we can get some information here. We also have the tail. You can also check the last 5 rows of your data set. So you can see the tail. Oops. All right, so the last 5 is also right here. Okay, so these are some information we get from our data, right? The next thing we are going to do is data sanity check. Okay, so one, we've been able to import our libraries, we've been able to read our data set. The next thing you're going to do is data sanity check. And with data sanity check, we are basically going to check the shape, the information, the missing data of our data. We also look whether there are uh, duplicate values in our data set. Okay, so the next thing we are going to do is check the shape of our data. So pf dot shape. Okay, and as you can see, we have 2,938 rows, okay, against 12 columns, 22 columns, sorry. Yeah, so that is our shape. We can also check the information. We will get more information from this side. So information, oops, so df information. As you can see, the class pandas dot, don't worry, this is a data frame, okay, and here you are giving us the range of index. So we have, as I said earlier on, 2,938 entries, which is our rows, okay, and it starts from 0 to 2,937. Okay, so that's the rows we have, and we also have columns, and we have 22 columns in total, right? And here we have the columns against their data type, okay, and also the counts, right? So as you can see here, we have country, year, status, life expectancy. For country is an object, which means categorical. We have year, which is integer, which is discrete numerical value, right? And we also have status, which is also categorical. Aside that, I think we don't have any categorical values again. The rest are floats, which are continuous data, and integers, right? So this gives us some information about our data, right? Yeah, so as you can, when you come down here, we have data types, floats, integers, objects, right? It gives us the number of each of them we have in our data set. All right, so the next thing you are going to check is we are going to check for missing data. Okay, in the missing data, we are going to, let's say, is now. So you are going to check for is now, right? And sum. Okay, so you are going to sum all the now values, right? So as you can see here, we have country, all the entries are full, we don't have missing data there. Same as year, status, but life expectancy, we are missing 10. We are having missing data, that is 10 missing data there, right? Same as adult mortality, we also have, which one again, alcohol, right? So as you can see, these are the number of missing data we are having in our data. Okay, so we can also print it in terms of percentages. So let me just go down, okay, here, and what you are going to do is, let me say, print, let me leave some information here. So, let's say missing values before, okay, handling the missing data, okay, or missing values, right? And right here, let's say we can, I just want to print it, okay, so let me just store it somewhere. So let's say data equals, and I'm just a lazy type, so let me just come and copy this, right? And then let me paste it here, because I'm sure the next time I will try to say df, I'm gonna say pdf again. So what I'm going to do here is I'm just going to divide this by df.shape, okay, oops, so shape, which is 0, and then we are going to multiply it by 100, okay, so that is going to be our data. And we can see now in terms of percentages, we have 6, so as you can see 18%, and then we have 15% on that, right? So these are in terms of percentages. So someone might ask what I did here. So for each of the columns, okay, we also know the shape, and as you can see here, we're just trying to get this, that is for the total, and we get 100%. Okay, so that gives us 100%. And dividing the missing values, right, over the total and then multiplying 100% is going to, or is supposed to give us the missing values for each of them, right? So that is just a basic mathematics I did here. So the next thing you're going to do is you are supposed to find the duplicates in the data. Okay. So here you're just trying to check whether there is duplicate. So I'm just going to type df and I'm just going to say duplicate. Okay. So duplicated, and we are just to sum all of them. Okay. We don't want them individual. So alright, so we don't have duplicates for now. That's great. And the next thing you can also check is they are all steps under sanity check. Okay. So the next thing you're going to check for is identification of garbage values in our data set. Okay. And we can just do this by just a simple for loop. So for in, and we can select, so we can select the data types by just df dot. When you click on the tab button, you are going to get some pop-up. And these are some of the things you can do with your data set. So we just want the data types, okay, which include numbers. So include, objects. Oops, objects. Okay, dot column. So let me use a second to finish and then I'll explain to you what we are trying to do here. So df.I, okay, and we are supposed to get the value underscore counts. Okay. Oops. Great. So that is also another function. And let me just try and beautify things here. Okay. So let me see some hash here. Let me just multiply it by, let's say, 10 or 20. Okay. And what you are trying to do here is, oops, oh my god, what's wrong? Okay, data types include, what's happening? Oh, it's objects, not objects, sorry. Okay, so let's try and, okay, great. So what you are trying to do here is looking at our data set, right, with our countries, for instance, the categorical values. There might be an instance that here will be, let's say, car. Sorry, let me, car, right? But clearly we know that car is not a country, unless, okay, maybe I don't know, but for now I know car is not a country, right? So for now we can see that car is an odd value or an odd variable under our country. Yeah, so the garbage here, we are just trying to get all the possible values for country and also for status. These are the two categorical values we have. Okay, so it prints all the categorical values and we look through all of them and verify whether all of them are supposed to be under that column, okay, or that feature. So as you can see here, it's concatenated it, but yeah, you can just take your time and also go through the actual data set and find out. But for now, let's take status for instance. We have developing and developed, okay, which are the only two uh, entries or types of entries we have. But for country, you have a lot, right? Which is 900 and 193, right? So yeah, okay. But for most instances or for most cases, what I'm saying, you will get it when you are dealing with other data. Okay, I hope you get it. So here you are just trying to, let me take it again for you for the last time. Then what you are trying to do is you are just trying to print out all the possible values under each of the categories, and you verify whether indeed they are. If some of them are odd, you can just go back to your data and delete them, or you can write an algorithm to go through and delete them for you. Okay, so the next thing we are going to do is we are now in statistics. Okay, so we are going to just view the data in different forms and shapes, spaces, and then you make some decisions out of them. Okay. So the first thing I'm going to say is describe the data for me, right? So describe. Oops. Good. And as you can see here, okay, let me transpose. Okay, so the T. Great, I like it this way. So here, as you can see here, we have the mean, we have standard deviation, the minimum value for year, we have the upper quartile, lower quartile, mid quartile, we have maximum year, life expectancy. So for all of them, you can get their mean, number of counts, and a lot of things from the describe. Okay, you can do same for country and then status, right? Because this is for numerical. Okay, so you can do same for categorical, which you are going to state here. Include objects. Okay, so include objects. Great. So here we see we have country, we have the unique values here, we have 900 and 193, right? As we got it from our the information we got here, see clearly we have it here. So the unique entries for our country, we have 193, right? And the most appearing one, the frequent one, was this. Okay, so I'm not going to mention the name. Yeah, so and it appeared 16 times, right? And as you can see, status, we have two. We have developing and developed. So again, come back here. See, we had only two here. Okay, so yeah, developing and developed, and developing appeared 2,462 times, right? Yeah, so at least we can see, we can make some, if not we know the mean for each of the columns, right? We also know the mode. All right, so the next step is we have to visualize our data, right? In 2D and also 3D graphs to see how our data looks. Okay, so the first one you are going to do is you are going to use histogram. Okay, so you are going to plot it with histogram and see how it looks. So you are going to say for I in, so just another simple algorithm. So I in df dot select. Okay, and we are going to select only numerical data, so number, right? On the columns. Oops. Right, and here you are going to use the CNN dot histogram. Okay, so here's plot, right? And we are going to pass our data. So our data is supposed to be our df, and our x is going to be our I, right? And we are going to say plt dot show. Oops. So all right, so as you can see, we are having our histogram chart for each of the columns, right? So as you can see, and looking through it, you can make some information out of them. You can also plot it or visualize the outliers. Okay, so that one too, you're just going to do the same thing. So I'm just going to copy this. So we can visualize our outliers right here. Okay, so the outliers basically means the data points that are out of the range between the lower quartile and then upper quartile. Okay, so those are the outliers, and let's try and visualize some of them. So I'm just going to say box plot. Okay, right, so it's the same thing, just that now you're not using histogram, you're using box plot. And let's try and then, okay, so as you can see, we have here, we don't have any outliers, but for life expectancy we have some outliers here. Okay, so the lower quartile is this, and then the upper quartile is that, right? So any data points that comes after them are outliers. Okay, so they are outliers, and yeah, these are outliers. Okay, so when you have too many outliers in your data, the more you have the outliers, the skewy your data becomes. Okay, so you have to deal with outliers. But for now, at least we know that our data set contains some outliers for which we are going to deal with them later. Okay. We can also visualize them using scatter plot. Okay. So now we've been able to visualize them with histogram, also visualize our outliers. Now we are getting to scatter plot. Okay. So with scatter plot, we actually have to mm, plot some of the columns against one column. Okay. So with this idea, or when you read this, when you read the information or the about of this data set, the main thing we can do is predict whether um, a patient or yeah, patient is going to survive or not, right? Which is the life expectancy. So yes, so this is our label. Okay, again coming back to that, labels and features. So this is our label, and the rest are our features. Okay, so we are trying to predict this using the rest of them. Okay, yeah. So what I'm going to do here is, let me try and say df dot. Just want to get all the columns. Okay, so df dot select data types. Okay, let me see, include number. Okay, dot column. Oops. Yeah, so these are the columns. So what I'm going to do is I'm just going to copy everything here. Oops. So I'll copy everything here, and I'm going to create a variable, say calls. I'm going to save everything here, and down here I'm just going to write another for loop. So for call, which is in calls, right? And here what I'm going to do is use our CNS scatter. So using our scatter plot, I'm just going to pass our data. So data, which is df, and you're going to pass our x, which is call now, and then our y is going to be our life expectancy. Okay, so where is it? Life expectancy. Okay, right here. So I'm just going to cut this from the column. Okay, then we are going to paste it right here. Great. So this is our life expectancy, and let me try and add some title. Okay, and our title is supposed to be, oops. Okay, so our scatter plot for plot for, then we are going to pass the column. Okay, yeah, so this is just for fancy stuff. So oops, come on. So another one for plot for our x label. Is going to be our call. Then the next one is going to be y label. And our y label, as we know, is our life expectancy. Okay. So now you can see PLT show. Okay. Hopefully everything works. Okay, so yeah, my bad. So let's run it. Oops. Y label. POT, sorry. Okay, so yeah, so this is our scatter plot. Yeah, so as you can see, we can get some information from our scatter plot as well. Okay, so life expectancy against BMI, against hepatitis B. Okay, so at least you can make some infant death. Okay, so yeah, as you can see here. Okay, So we can make some information from this, right? Yeah. And the next thing you're going to tackle is you can also check some correlations between the features. Okay. So exactly what I did here. So I'm just going to copy that and I'm going to bring it here, and just instead of columns I'll just say call. Okay, just for correlation, and I'm going to save it inside a variable called correlation. It's okay. Let's run it. Hopefully we don't get any error. Okay. Oops, let me paste it right here so we can see the right. So as you can see here, I can get the correlation between year and itself, year and then life expectancy, adult mortality and year. So we can also visualize it using the heat map. Okay, and that is just going to be plot. Okay, because we already have the correlation. So plot and figure. Okay, and then the figure size. So figure size, which is let's try and give it 15 by 15. Okay, and then let's use our heat map. Okay, and in our heat map we have correlation. Okay, the correlation, which is what we are passing as our data, and then just not okay. Oops, true. Okay, then let's the decimal points, let's leave it at two decimal places. Okay, so that's going to be point 2f, and then also the line width, let's say 0.5. Hopefully everything should work. Okay, so as you can see we have a correlation here. Okay, so we have a heat map, and this is the bar. Okay, so when it's high, that is high correlation. Oops, yeah, when it's approaching 1, that is high correlation. When it's approaching 0, that is low correlation. So that is the color representation of that here. So we've been able to visualize it using our heat map. So quickly let's move on to handling our missing data. Okay, so with handling our missing data, we can choose to use different approach. Okay, which we can use either median, mean, KNN imputation. We can use constant imputation. Okay, but for this video I'm going to just stick to median or mean imputation and also KNN. Okay, so we are going to have a taste of KNN as well. So the first thing I'm going to do is for the median. Okay, so for I in, and I'm going to provide the columns I want to fill. Okay, and after that what I'm going to do is df I. Okay, so we are going to fill the now values. Okay, with our median for each of the columns. So column I dot median, right? Oops. Place true. Okay, so here what you are trying to do is you are going to pass in some number of columns. Okay, and for each of the columns, the algorithm, or this simply the for loop, or the algorithm here is just supposed to find the median for each of the columns and then replace all the null values, right? That's why we have the fill now here, all the null values with the median for that particular column. Okay, so let me try and explain it using this. Okay, so as you can see here we have a lot of missing data here, so it's just going to take the median of this column. Okay, and then wherever it finds empty spaces, it's going to fill that these spaces these spaces with the median value. Okay, that is basically what you are trying to do here. So before then, I want us to again check for the missing data. So here, let me just say fill this now. Dot sum. Okay, so you can see here we have life expectancy, we have H hepatitis B, we have BMI. Okay, so let me see. Okay, let me bring this one down. I would like to use it. So I'm just going to bring it down. So these are some of the, let me see, BMI. I'm going to take this one. Okay, just copy everything like this. You see there are spaces here. If you don't bring the space, you can encounter errors. Okay, so that, and also let me choose another one. Let me see, income. Okay, let me copy this one as well. So I'm just going to copy this too, and I'm going to paste it here. Okay, so these are the columns I would like to. Okay, let me add another one. These are the columns I would like to perform the median imputation on them. Okay, so before we perform the median imputation, I would like us to take a clear look at these values. So here we have 34, right? And then here we have 19, right? And income composition, sorry, we have 167, right? So let's try and then run this. And I would just want to, so let me create a new cell here and paste it so that we can compare it with what we had previous. So let's go to BMI. As you can see, 0. So now our values has been replaced, right? And also income, right? So when you check income now is 0, right? But previously income was 167, and the last one was polio. So as you check, it's 19, but when you come here, it's 0 now, right? So it means our median imputation worked, right? So now I would like us to also perform KNN imputation on the rest of them. Okay, so that one too, I'm just going to write a simple algorithm here. So first of all, I'm going to from SK len, okay, impute. So I'm just going to do some imports, the KNN imputer. Okay, so KNN imputer, and I'm just going to create an imputed data, right? I'm going to call this function right here. So it's going to create imputation right here, and let me just comment them. Okay, so everything is on point. Just wanted the results to go away. Okay, so with the KNN imputation, after running this, let's try and create another cell below it. Okay, and for this cell is another. So here we're going to select. So here we are just going to use all the columns. Okay, because I just don't want to take everything and then now remove them again. So I'm just going to say select data types. Okay, which we're going to add include number, right? We want the columns. So, okay, and DFI equals imputed. Okay, dot fit transform. Dot fit transform. We are going to pass in the DF. Okay, mind use double curly braces, right? That is square brackets. Okay, so what we are trying to do here is we are imputing for the KNN imputation. Okay, so imputed value. So what you are trying to do here is we are creating an instance of the imputer, and then we are going to transform for each of the columns. Okay, you pass in the columns, the values, and we are going to get the inputted values for each of them and then replace them here. Okay, I'm sure. Okay, so let me try and explain what the KNN does is it takes, you see, with the mean and median, right? That one, uh, how should I explain it? So let me, okay, Hmm, okay, so let me see. So what I'm trying to basically say is with the median and mean, that one we just find the mean or the median and then we fill that data with it. So it means when filling this data, these missing values, right? We just concentrate on this column, right? And then we find the median of that and we fill this one with that. Okay. But there can be instances where adjacent columns, okay, can have impact or influence on this column, right? That is when you bring in KNN. Okay, so that is K nearest neighbor. Okay, so you are trying to use the neighbor columns, okay, to also have impact in the values you are providing inside or for a particular column. Okay, so that's when you use the KNN. And I hope this will try and then explain a little bit for you. So let me try and say KNN imputation. Okay, so you can just go to their website and then check. So it's designed to find the k nearest neighbors for the missing datum. Okay, that is incomplete instance from mobile. So you can just read about it. Okay, method that is works in k nearest neighbor that identify neighboring points through a neighboring distance. Okay, missing. So yeah, you can just read a lot about it. Okay, but for now, just know we have constant imputation. With constant imputation, what you do is the same thing as the mean, but rather you just fill here with constant number. Okay, you don't fill it with the mean, you don't fill it with the median, fill it with a constant number. So let's say 0, 2, 10 or something, right? Yeah. With mean imputation, you fill the side with the mean of the column. Okay. So when you calculate the mean for the data that are available, you fill these ones with the mean. With the median, calculate the median, fill this one with the median. With KNN, the neighboring columns also have influence. So you don't just base on this, but the neighbor. Okay. Any column that have influence on this column will be considered. Okay. They will account to the value that will be placed here. Okay. Yeah. So I think that is it for KNN. So let's go back and then let's go back to KNN. Let's run it. Hopefully it should work. Okay, so that one is also perfect. So now when you run our null again, now you see we don't have any missing values. Okay, so now our data is filled. And okay, let me remove this. And also remove this one as well. Okay. Yeah, so the next thing you are going to deal with outliers. Okay. Yeah, so let me create a cell here. So here we are going to create a function to calculate for our lower and upper quartile. Okay, and based on that we will use it to write some algorithms and also a lot of things. Okay, so without wasting my time, I'm just going to paste the code and then I will explain it to you. Alright, so as you can see here, we have a function called whisker and it takes in a column, and for that column it tries and calculates for the lower quartile and upper quartile. Okay, and yeah, so that is basically what it's doing here, and it returns the lower and then the upper, okay, with which is the lower and upper quartile. Okay, so that is what this function is doing. Again, this is mathematics, right? Or statistics. Okay, so you can just copy this or just find it, what the way you think you can use to get your lower and upper quartile. Okay, so once you are done, then we can move on to the next stage. Okay, so here when you call this function here, So let me just call this function here, and I just want any column. So I can just say life expectancy. Okay, copy, and when I paste life expectancy here, so this column, oops, okay, I've not run this one, sorry. After running that one, just okay. So you see now we are being provided with our lower quartile and upper quartile for life expectancy, right? So in order to check that one, you can just come to your outlier, okay, where you plotted it. So we can, oops. So let's see. Life expectancy. Okay, so as you can see here, okay, the graph is not actually giving the right range, but that is our lower quartile and upper quartile. Okay, and so with these values we are getting, we can write an algorithm to check if there is data points that are below this. You should replace those data points with this, right? And if there are data points that are above this, you should replace those data points with the upper quartile. Okay, so that is the next algorithm, the next thing you're going to do. All right, so as you can see, I've just written the code here. Okay, so I've chosen some of the uh, columns, okay, and I want to perform it on it. So what you are trying to do here is we try and get for each column, okay, we get the data for that column inside our whisker function, and it provides us with the lower quartile and then the upper quartile. So here we are trying to say if the this is for the lower quartile, right? So if the data points for the first row is for that column is lower than the lower quartile, fill it with the lower quartile, or fill it the same one, which means it should remain the same thing, right? Yeah, so same thing for the rest, okay? So for upper quartile too, if the data point inside the data set is bigger than that, then replace that with that. So as I explained to you earlier on with this one, that is exactly what this one is doing, okay? So before you choose your columns, okay, these columns, you have to go back and check for your data set, okay? So let's say in reality, or yeah, in reality, life expectancy is supposed to be within, let's say, 40 to 90, okay, and that is exactly what you have, but with the lower quartile and upper quartile, it's going to truncate these values out of there, but in reality they are supposed to be part. If that is the case, then you have to leave them, okay? So you have to have a fair idea about the range of values you need, okay. So if you have the idea about the range of values you need, you can decide to perform the outline, like removal of outline from some of them, okay? So you won't perform it on all of them. So that's why I chose some of them, and we mostly perform them in continuous data sets, okay? Yeah, mostly, but you can perform them on discrete data set as well, but it's weird to perform them on categorical, honestly. Yeah. So that is it for that. So let's try and then run it and see if everything works. Is that everything works? So you can just go back and then let me see. You can just come back and then see whether we've been able to clear our. So we come here. So I'm just going to create a new cell here. I'm going to paste that and let's see. So here I'm just supposed to pass in the columns for this particular data. So I'm just going to remove this and replace that with this, okay? But yeah, I'm just interested in only these ones. So let's run it. Hopefully there should be. Okay, so you see now our outliers has been eliminated or has been dealt with, right? So what it basically did, as I explained to you, let me take it for the last time, is it takes, let's say for instance, life expectancy, or let's say total expenditure, okay? So it takes that, find the lower quartile, okay? So each data points that are below the lower quartile, replace those data points with the lower quartile value for that, right? And it takes the upper quartile, right? And each values that are above the upper quartile, you replace those values with the upper quartile. So it kind of truncates them so that they can be within that same range. Okay. Yeah. So that is how we dealt with our outliers. So now let's try and check whether we again still have duplicates. If we don't have, then hallelujah, we just move on to encoding. But if we have, then it means we have to deal with that. Okay. So I'm going to create a new cell here and I'm just going to type df duplicated. Okay. Let me just say sum. Okay, so okay, we still have 0. Yeah, so let's say if we did had duplicate values, then we can drop them. Okay, and we can just do that by saying df equals df dot drop duplicated. Okay, so we'll drop duplicates, drop underscore duplicates. Sorry. Yeah, so this is how you can drop them. Okay, and then you just pass everything to the df again. That is if you have duplicates, but if you don't have, you can nothing happens. Okay, yeah, so now we are in our final stage. Okay, it's been a long, yeah, and I hope you're enjoying. So in our final stage is encoding. Okay, so back to our data set. As you can see here, our country is categorical, our status is categorical, the rest are numerical, which our model, that is the best language our model would understand, right? So for country and then status, you have to convert them to numerical. Okay, and okay, so we have two types of way we can go by it, and it's all depends on the data, the type of categorical data you have. Okay, so if you have nominal data, then the nominal data, we don't have any range or rank for our data set. Okay, so for instance, this is a clear example. You're talking in terms of fruits of a color, or let's say colors. We have red, green, blue, indigo, violet. Yeah, we have a lot of colors, right? And I don't think we have a range for colors. Let's say color A comes first, even though we have primary colors, but we actually don't have range for. Okay, for instance, when we take the primary colors, we don't have ranges for them, ranks for them. Okay, so in that case, it's nominal data. Okay, nominal variables, and those ones we perform nominal encoding for them, right? And then let me show you how we perform the nominal encoding. Yeah, so with a nominal encoding, we create new columns. Okay, so we take the title of this, which is color, and then we map it against red. Okay, to create a new column, and then in that order. Okay, so let's say for instance the first row, the color is red, right? Meaning it's not blue, it's not green, right? So we give red 1 and then the rest is 0. Okay, the next rule is blue, right? It means blue will be 1, the rest will be 0. So this technique is what we term as one hot encoding, right? Yeah, so this is done for numerical data values, right? And we have ordinal encoding. With ordinal, it's just the opposite of nominal. With ordinal, the categories has ranks. We have a category for the level of education. Okay, so education level. We have high school, we have college, we have graduate school, right? Ideally, we know that college are much higher than high school, and then graduate school is on top of these two, right? So in that case, we can encode by giving them values. Okay, so high school will be 0, which means that one is lowest. Okay, college will be 1, graduate will be 2. Okay, so in this case, there are ranks within them, and with nominal, there are no ranks. Yeah, so this is another example of it. Okay, so we are using one hot encoding here, fruits. So as you can see, as I said earlier on, under fruits we had apple, banana, and then kiwi, right? So here, just trying to get the colors for them. So color green, color red, color yellow, right? So it means apple is red because under one hot encoding that is 1. Under one hot encode we can't have one here. For the rule, all the columns, it's only one that is supposed to be allocated with the value 1. The rest are supposed to be 0. Okay. So banana is under color yellow, right? And then kiwi. Do that one for yourself. And then leave it in the comment section. Okay. So as you can see here, we have ordinal encoding. Okay. With ordinal, we have person, Alice, Bob, and then Charlie. So you have level of education for them, right? And we have high school, college, and graduate school, which is 0, 1, and then 2. Okay, so that is basically the idea behind encoding. And let's try and then just encode. So as you can see with our data, yeah, I think it's nominal. There is no order for them, so we are going to use a simple nominal encoding. Okay, and that is basically what I've done here. So PDF gets dummies, and then you pass your data, your column, so our country and status. And when you run this, it's supposed to perform that for you. You can see where is our country. Okay, let me try and then. Okay, so with our country, we have United States of America, false. Country Uruguay, false. So as you can see, which is going to increase our columns, honestly. Earlier on, we had 22 columns. Now see the columns we have 213, right? So it's kind of going to increase it. That one you have to bear it in mind. But for ordinal, it's not going to increase it. But for nominal, it's going to increase our columns. And I think right now we can save our data, and any model we perform, like we train it with this data, the model is going to perform. Trust me, because we've been able to go by it. And you can just get this down. Okay, so first you import your library, you read your data set, check sanity checks. Okay, perform sanity check on your data, exploratory data analysis, and you handle your missing values. You treat your outliers, and also check whether they are duplicates. If they are, you try and then remove them or drop them. Okay, check your garbage values, and you perform your encoding, right? So these are the steps that we've been able to use to train our data. Sorry, to pre-process our data. And I hope you really enjoyed. If you did, kindly let me know in the comment section. Like this video, share with friends, and see you in the next video.